Hi, this is Algebra 2, Lesson 3-4, Dividing Polynomials. In this lesson, we'll be able to divide polynomials. Lesson vocabulary is factor theorem and also remainder theorem, synthetic division. Let's start with explore and reason. Benson recalls how to divide whole numbers by solving a problem with 6 as a divisor and 83 as a dividend. He determines that the quotient is 13 with remainder 5. Looking at his work, explain the process of long division using Benson's example. So this is easy. You know how to multiply and divide real numbers, right? So let's explain what he wrote here. He divided 83 by 6 by looking at how many 6 goes into 8 and subtracting it and looking at how many 6 goes into the difference of that. And you have a remainder of 5. So I'm going to type the answers here on top. To divide 83 by 6, first figure out how many times 6 goes into 8. It goes in 1 time. So write a 1 above the 8. Multiply 1 by 6 and write the answer below the 8 and subtract. Bring down the 3. Ask how many times 6 goes into 23. It goes in how many times? 3 times. So write a 3 above the 3. Then multiply it by 6 and write the 18 below the 23 and subtract. Since 5 is less than 6, it is the remainder. And the quotient is 13. Okay, good. Now, how can you express the remainder as a fraction? So you have 5, which means you divided 83 by 6, and then 6 goes into 83 13 times, but you have a remainder of 5, and 6 cannot go in there. And so you can say that 5 out of 6 is remaining. So I'm going to type it right below. Write the remainder as a fraction whose numerator is the whole number, remainder, and whose denominator is the divisor. So just like 5 over 6. Okay. Part C. Use the results of the division problem to write 2 expressions for 83 that include the divisor, quotient, and remainder. So how can we rewrite the equation for 83 where we use all these numbers, the quotient, divisor, and remainder? So again, we can say that 6 times 13 plus 5 would be 83, or 6 times 13 and 5 or 6 would also be 83, right? This is very important because later when we think about polynomial division, we are going to use the same rule, okay? So 83 is the same as 6 times 3 plus 5. And then another expression that we could represent using the division is 6 times 13 and 5 over 6. Okay, so now we have explored how to use long division for numbers, right? We learned this like several years ago. We're going back to pre-algebra, but why are we doing this? Because we need to understand that long division works like this, and we remember it so that we can divide polynomials in the same way as well. So the essential question for this lesson is, how can you divide polynomials? So we're going to explore the different cases to divide polynomials. Let's start with example 1. Use long division to divide polynomials. How can you use long division to divide p of x by d of x? Write the polynomial p of x in terms of the quotient and remainder. So let's look at the first example. How do we divide x cubed plus 5x squared plus 6x plus 9 divided by x plus 3? Well, we're going to use polynomial long division. So remember that long division in real numbers with the real numbers works like this, where you look at the divisor and see how many digits go, how many divisor goes into the digits, the minimum digits, right? But looking at the polynomial, you look at the divisor, right? It's a binomial here, x plus 3. So so we're going to divide by x plus 3, but first you have to match the leading coefficients. So your leading terms will be matched. So look at x and x cubed. You want to know how many x which times x would give you x cubed. So we're not thinking about how many x would go into x cubed. You're going to multiply. You're finding the factor that will multiply to make it equal. Okay, so x times x squared would be x cubed, and then once you figure that out, you have to multiply this term by your whole binomial, because you're not dividing it by just x, but you're dividing it by this binomial, right? So x squared times x plus 3 would give you this binomial, x cubed plus 3x squared. So you subtract that to get rid of the first term, and this is the goal of why we're matching the leading terms, okay? And then we're going to subtract 5x squared minus 3x squared because they're like terms. And so we have 2x squared, and then you put the 6x and 9 down. And then you're matching the leading terms again. X times 2x will give you 2x squared. So you multiply 2x by the entire binomial, you get 2x squared plus 6x, and then you subtract, oh, they're gone. But the binomial x doesn't go into 9 anymore, so that's your remainder. So what if you have a remainder? How would you write it as an answer? This is something that we already looked at in our introductory lesson problem, explore and reason, right? Part C. If you divide the numbers using long division and you have a remainder, you can write it as 6 times 13, so whatever your divisor is, times whatever you got for the factor, plus the remainder. Or you can multiply by the divisor times your number, your factor 13, and 5 or 6, so your remainder over your divisor. So there are 2 ways you can write the polynomials when you have a remainder as well. So first, we know that we're going to have a factor of x squared plus 2x. We can write it as x squared plus 2x plus 9 out of x plus 3 would be our answer, our factor. Or you can also write it as your dividend, x cubed plus 5x squared plus 6x plus 9 is equal to your factor, your divisor, x plus 3, times your quotient, x squared plus 2x, and then plus 9. Okay, so they're actually the same thing. If you look at the equation here and the equation here, you'll notice that they're actually the same thing, but the divisor is multiplied out here so that it's canceled out with the divisor here, but you're also multiplying divisor here. Okay, so quotient times divisor plus remainder is the same as quotient plus remainder over divisor. Okay, so I hope that made sense. Let's look at another example, part B. What if you have something like this, 8x cubed plus 27 and 2x plus 3. And now you'll see that you don't have all the terms. You have the biggest term, x cubed, and you don't even have x squared or x term, right? That means your coefficient is 0, and you need to fill that in because you need all the terms when you're doing long division. Okay, so just plug it in with the coefficient 0, and you do the same thing. 2x times 4x squared is 8x cubed. So then you multiply 4x squared with your binomial, 2x plus 3, and then you get 8x cubed plus 12x squared. Then you subtract it. And you have negative 12x squared, and you do the same thing. Negative 6x times 2x, you match the leading terms, is negative 12x squared, and then you multiply the whole binomial. And then you keep doing it, and there is no remainder for this one, so it's a nice little factor, 2x plus 3 times 4x squared minus 6x plus 9. Alright, so let's look at try number 1. Use long division to divide the polynomials, and then you're going to write the dividend in terms of the quotient and remainder. Okay, so pause the video and see if you can solve this by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at try number 1, part A. Alright, so you divide this by this, right? You're going to use long division. I'm going to write it here. Okay, x cubed minus 6x squared plus 11x minus 6 all divided by x squared minus 4x plus 3. And now instead of a binomial, we have a trinomial, and that's okay. It's still the same rule. So look at the leading terms, and you're going to match it. X squared times x is x cubed. So you're going to multiply x with the entire trinomial, and you have x cubed minus 4x squared plus 3x, and then you're going to subtract this whole thing. And so your leading terms are gone. And then you have negative 6 minus negative 4. That's negative 2x squared. And then 11 minus 3 is 8x. And then you have negative 6. And then you match the leading term again. X squared times negative 2 would be negative 2x squared. And then you multiply negative 2 with the other terms as well. You get plus 8x and then minus 6, and oh, look at that, you have no remainder. So writing this as the quotient and remainder, you will get x minus 2 times x squared minus 4x plus 3. Okay, good. Let's look at part B. 16x fourth minus 85 divided by 4x squared plus 9. This one, you probably had some questions in the solving process. It's just like example B, example 1B. Okay, you have to write the entire polynomial with the coefficients that are missing. Okay, 0x cubed plus 0x squared plus 0x minus 85. Okay, sorry, my handwriting looks really bad. And then you have 4x squared plus 9. Okay, and then you're going to multiply and match the first term by your first term here. So 4 times 4x squared times 4x squared would give you 16x to the 4th power, right? So you just write that. And then you multiply this and you get 16x to the 4th power, and then you multiply that by 9, and you get 36x squared, and then, yeah, put it below the matching term, and then you're subtracting this, right? And so this is gone, but you don't have 0x cubed, so that's gone as well. And then you have negative 36x squared, and then you have 0x, and then minus 85. And so how many 4x squares goes into negative 36x squared? So try to match this. They're the same term, but you can still multiply 4 by 9, negative 9 to get negative 36x squared. And you multiply negative 9 by positive 9, and you have 81, negative 81. And then you're subtracting them, so this is gone, and then you add 81, so it's going to be negative 4. All right, so you have a remainder of negative 4. You're going to write it in terms of the quotient and the remainder. So you can write these two factors, 4x squared plus 9 and 4x squared minus 9, and then the remainder. So you'll just subtract negative 4, okay? So let's write the factors. 4x squared plus 9 times 4x squared minus 9, and then you will subtract the remainder, negative 4. All right, so that was example 1. Try it 1. We'll continue with the next example in the next video.